Welcome students. This is the third lecture for the theory of surfaces. For better understanding, you must watch the previous lectures on the theory of surfaces. Today, we start with the definition of metric. Let R of UV be a surface of class G defined in domain D. Let U equals to alpha of t and V equals to beta of t be a curve which is lying on the surface. If the arc length is S, then ds dt whole square equals to E into du dt whole square plus 2 into F into du dt into dV dt plus F into dV dt whole square, where E equals to R1 dot R1, F equals to R1 dot R2, G equals to R2 dot R2. You can pause the video to note down the derivation. In terms of differential, ds whole square equals to E into du whole square plus 2 into F into du dV plus G into dV whole square. This expression is called the metric. It is clear that from above derivation, E and G greater than 0. Now if we use the relation R1 cross R2 whole square equals to R1 square into R2 square minus R1 dot R2 whole square. Since R1 cross R2 whole square greater than 0 implies H greater than 0, where H equals to mod of R1 cross R2. Now using the above inequalities, we can say that the metric is positive definite. An important observation. The metric is used to calculate the arc length, but EF and G are playing important roles in other ways. Now we derive the angle between two parametric curves on surface. Let the angle between two parametric directions R1 and R2 is phi. Then we have cos phi equals to F by square root of E into G, and sin phi equals to H by square root of E into G. Now we investigate the element of area. Let us consider four parametric curves as shown in figure, where we can see 4 points of intersection. Now if dil U and dil V are so small and positive, then the figure is approximately a parallelogram whose adjacent sides are given by the two vectors R1 dil U and R2 dil V. Therefore the area dA equals to H into dil U dil V. At last, we prove this theorem, which states that the metric is invariant under parameter transformation. Now let us begin with the surface R. Let us consider a transformation U star and V star as a function of UV, and R1, R2, E, F, G, and R1 star, R2 star, E star, F star, G star defined as per rule. Therefore the metric in new coordinates U star and V star is E star into d u star holds square plus 2 into f star into du star into dv star plus g star into d v star holds square. Since R1 star and R2 star can be written in terms of R1 and R2. Inserting these values we get E star into D U star holds square plus 2 into F star into du star into dv star plus g star into d v star holds square equals E into d u holds square plus 2 into f into du into dv plus g into d v holds square. Hence the theorem is proved. Thank you for watching this lecture. You can note down this explanation. If you have any query regarding this explanation, you can write down in the comments section.